Okay, guys. Okay, all set now. Welcome everyone again. My name is Jatin, and in today's series, I'm going to discuss about the next topic which we have in our discussion called as Python Pandas. Now, I wanted to introduce you with Python Pandas before we proceed further with the couple of data frames or series which Python provides. So, in the last sessions, we have learned about NumPy, we have learned about uh, SciPy. We discuss about different kind of data science concept. In this particular section, I'm going to discuss about Pandas framework, which is one of the important framework for every data scientist user. Now, I hope that you have reviewed the previous sessions because that is more important to understand this particular section because it requires a previous understanding of NumPy to proceed it further. Now to get it started, so a few of the slides I have, then I proceed with the executions which I normally does. So let's see what is Pandas. So Pandas is a Python package for providing fast, flexible, and expensive data structure. Now Pandas is quite unique name. How this name actually came into existence? It came into existence because of a word called as panel data. Now what is panel data? I have put this description over here. So it says the name is derived from a term called as panel data, an economic term normally used for multi-dimensional data structured data set. So that's why the name pandas came into picture. It has nothing to do with the animal. So it's about a panel data in which it provides you the expensive data structure which can be used for data analytics or data manipulation. It provides a lot of functions like grouping, appending, concatenating, doing the standard deviation, variances. A lot of functions are available in pandas. We are going to explore all those functions in these classes. So what I have done is I have divided this complete section into multiple parts. So today I'm going to do some part, tomorrow again I'm going to do some part, but I make sure that you get a complete understanding of pandas module while looking to these video sessions. Now it says that data structure design in pandas to make it more relational and label data. Like for example, you have seen in Excel files or you have seen in any relational databases. Like you have a table in which you have the column as well as you have the rows. So similar kind of representation pandas provides you that you can label your data, you can define your indexes, you can you can fetch out this information from this labeled information and do the manipulations very easily. So that's what we are going to look into this particular session. So Pandas is most powerful and flexible open source data analytic manipulation tool available in Python. It's an open source. It is licensed under BSD, uh, and it is highly useful if you want to do any kind of customization into it. You can do it. Look into the source code, and you can do it. But make sure that you have done it pretty good. So, and the beautiful part about this pandas is again it's built on NumPy. So in last section we have discussed about how NumPy is providing you much beneficial as compared to normal Python. Whereas NumPy was much faster as compared to normal Python. We have seen one example into it as well. Now pandas is built on NumPy, so execution speed is pretty good, you know, and it is provide you a lot of scientific operations and providing the integration with multiple three third-party libraries. So we are going to look onto those use cases, different kind of scenarios in which we get a data from the web and do the analysis on the top of it. We get a data from a different kind of databases, might be CSV file or JSON object, or it might be from Excel file and doing the analysis on the top of it. So pandas is used very heavily in most of the analytical softwares. It can be a financial or a statistical information or social sciences as well as many other engineering area. So let's proceed further with the next structure. Now this is very important to understand that Python provides you two different kind of data structure. One is called as a series, another one is called as a data frames. So I open my notepad so that I can write it down. So the first one is called as a series and the second one is called as a data frame. Now both are highly useful to understand that how Python is actually storing the data in the memory, and we can process this information directly with the help of these structures. Now, the beautiful part about these data structures are they are easy handling of missing data and adding, removing of columns. So in case if I want to add more data to it, and if I want to handle those missing information, sometimes happen. Let's say in the last example we have seen, once I was extracting a data from Standard and Poor of different shares, there was some information which was missing. So Python pandas handle those information pretty easily, and you can modify it, you can update it, you can delete it as well, and you can put some default value which might be zero, I would say, whenever you try to find out some interpretation from the data. Automatic data alignment and powerful flexible groups by functions to perform operations on a data set for both aggregate and transformation data. Now, you might have learned into your SQL classes that, let's say, for example, I have two different database table. Now, I want to join these two different database table and form a single data set out of it, or maybe I need to group by some specific columns and get the result, get the aggregate result directly from the data set. So all those things which we are going to learn in a class, and let's see how beautiful Python pandas is able to handle those scenarios. And I simply say it's a one-line step, so we understand this step by step. Once we understand the data, then I can directly jump into different use cases and give you multiple examples of a data set. It's intelligent, label slicing, fancy indexing. This is common things. Easy merging and joining data set, as I've discussed earlier. Flexible reshaping and pivoting of a data set. Robust input-output tool for loading from a flat files. So I say Excel files, CSV files, stat files, JSON files. You can directly read a data from it with the help of a built-in functions available in Pandas and process this information directly into the memory of Python. So let's get started with the first uh, data structure which Python provides, is called as series. So series is a single dimensional structure. It's a single dimension structure, single dimension structure, dimensional structure, which does not have any column. I would say it has only rows. So if you talk about the syntax of defining a series, the syntax of defining a series is pretty simple. Let's say, for example, I first import a pandas module. Now make sure that either you can use Anaconda. In last classes, I have told you how to install Anaconda into your machine. My spellings are always bad. Anaconda, okay, Anaconda Python. So in this specific, I'm using 2.7. Okay, because there are some use cases in which 3.x have a different set of syntaxes. So I'm using here Python and I got a 2.7, and I'm not in factly using Anaconda Python here. I'm using directly normal raw Python, which I have installed, and I installed Pandas module directly to it. So how to install the Pandas module directly to it? You go to your console here. I say pip install Pandas. That's it. So it installed directly on your machine. So my machine is already having this Pandas module, also having the dependency module which is required for Pandas. Everything is already installed. You can immediately start using it. But I strongly recommend that you guys should use Anaconda for any kind of utilizing Pandas into your namespace. So the very first thing is I have to import the Pandas. I want that this Pandas, I don't have to use Pandas each and every time. So I say PD. I basically create an alias. So I'll say import pandas as PD. So I created an alias of it. Now I start using uh, uh, pandas and defining multiple structure. The first one which we are going to define is called a series. So how to define a series? I say S1 is the name of an object I want to create. I say PD. PD is the name of a module, which is pandas. I have created alias of it, and I have a function called a series. Make sure that S is capital here. This is the function name, and this function contains multiple kind of attributes. I'm going to utilize here two attributes. One is called as a data, other one is called as an indexes. So if I want to define my name index, I can say index over here. If I don't want to define it, I can simply say data. By default, it takes an index. Now, this data is an iterable object. It can be your string, it can be your list, it can be your dictionary, or it can be your numpy array, or it can be any data structures you have learned so far. So you can utilize it. So let's quickly use this. So I say import pandas. I'm using an ideally here. Import pandas. It takes time because it's a little bit heavy module. Okay, oops, I say import pandas. I have to take an alias so that I don't have to use pandas and pandas each and every time. Okay, load it fast, please. Okay. Okay, so it's loaded. Pandas is available into my namespace. I create an alias quickly here. So let's create an alias. I say import pandas as PD. Now my PD is available. Now I want to create a series out of it. Let's create our first series. That series is S1. I take the name S1. It's a random name I have taken. I say PD dot series is my name of a function. I take a data. Now in data, I simply take a word called as Python. Okay, that's simple. I says S1 equals to PD dot series, and I say Python. Now if I try to print S1 here, it gives me the index number corresponding value. So the index number is 0, corresponding value is Python. So that is my S1. If I want to find out the indices, I say S1 of 0. It gives me the first value which is available at this index, a 0th index. So I have created with the help of string. I can also define my indexes. Okay, so I put index over here. So I say index equals to, I give, okay, it is a course. I give a tuple here. Okay, now my S1 is created in which the index's name is course. I have defined the course here which have a corresponding value Python. Great. Now if I want to find out I want to give that index, so I say S1 and I give course here. It basically prints the value Python, which we have learned till now. Now that's good. This is how we can create a series. So I'm using here a data directly. Here I'm using the indexes. If I don't use any kind of indexes, by default index starts from 0 and proceed further. That's an example of, I would say it's a string. Let's proceed further. So normally this data, the data which we have taken here, I told you that it can be a string, it can be a list, it can be a dictionary, it can be a tuple, it can be a numpy array as well. So we can create it. Let's see some examples. So let's say, for example, if I want to create a series, I say S1 equals to, I say PD dot series. I provide some value here. Let's say, for example, I give now uh, this list. So now my S1 is created, which have three values now. So it creates a 0th index, first index, and second index, because I did not provide any indexes over here. But if I want to provide an index, I can do that. So index equals to, I give some random value. I say 1, I say 2, and just, okay, I say 3. So I created three indexes, 1, 2, 3, which has a value 1, 2, 3. This is I just created with the help of list. Similarly, if I want to create with the help of tuple, this is pretty easy. I use a tuple here, okay, and I say, okay, this is created. One very important point, whenever you're creating a series, make sure that you have similar kind of indexes as defining the number of elements you have in an object. Now, if I say like this, let's say, for example, here I go back, I say, okay, I have only two indexes, but I have three different values. Now, this kind of example does not accept it. Okay, why? Because you have defining the indexes of two elements. The third element does not have any index. So make sure that the number of elements or items you have inside this object, the same kind of indexes you provide. If you are not sure the number of elements you have over here, you can immediately leave it. So what it will do, it will take the default indexes. Now it's pretty simple, but make sure that you follow the rules of this particular frameworks. Okay, so similarly, like we have created the series using list, string, as well as tuple, I'm going to create a series with a most common data we have is called as dictionary. So I'm going to create a series. I said ds1 equals to pd dot series. I provide a dictionary in a data, and in dictionary I provide some element. Let's say I put it like this: 1, 1, 2, 2, and I said this is 3, a string 3, and corresponding value. Pretty good. Now the beautiful part about dictionary is whenever I decide a dictionary and create a series out of it. Now what series is, it takes these keys as its indexes. So 1 is a key, 1 is corresponding value, 2 is a key, 2 is corresponding value, 3 is a key, and 3 is corresponding value. So if I try to print S1, I can see 1 is a key, 1 is a corresponding value, 3 is a key, 3 is a corresponding value, 2 is a key, and 2 is a corresponding value. Now, the beautiful part is if I take an indexes, I say index equals to, now instead of taking 3 elements, I take only 2 elements, which is 1 as well as 3. Now, how it behaves, now in other examples, we have seen that indexes should be equals to the number of elements or items we have passed over here. Now in this particular case, I have only 2 in indexes and we have 3 items here inside your data. So when I run this, it won't give me any error. Okay, what it does, it basically create a series with these indexes and ignore the indexes or a key which we did not provide inside indexes. This is one of the special case. Let's say for example, if you receive a huge amount of data, okay, and you are not bothered about some of the information into it, so what you can do is you can provide the indexes which you are more interested in and escape or do not provide those indexes which you really don't want it. So that's how you can manage defining a series with the help of dictionary. Now you can also define the series using complex structures. Let's say for example here I'm going to define a series. I say pd dot series. I define a structure here which is a list of list. So I define some list of lists. Let's say I define some name. I define my name. I say Abhinandan. Okay, I say couple. So and I say also Sachin. Now these all are the trainers at Ethan's. Most of the data science trainers. And I define their age as well. So Jatin is 35 years old. Abhinandan is 28 years old. Kapil is 38 years old. Now I'm just giving the random values. I'm not sure Kapil is 38 years old or not, but he has a lot of experience, so assuming it. And let's say Sachin is 32 years old. So that's how we can define a series. And here, when I define this particular series, I give a names as well as I give the age. Okay, but I did not define any indexes. So S1 is created, which has 0 as their default key. Corresponding value is the list I have taken over here, and 1 is the age. If I want to define the indexes, I can give it over here as well. So I say I have 2 indexes. I say index equals to, I say name comma age. Okay, that's good. Now S1 is created, which has name. Now let's say for example I want to fetch out Jatin out of it. So I say S1 of name, which is my complete list. It give me the complete list, but I specifically want Jatin, so I give 0 here. And if I want to print the age of Jatin, so I say S1 age, I say 0. Oops, I say 0 here. So it gives me the age of Jatin, which is 35. Now that's very simple. You have even though if you are not aware of what is list, you can immediately look into the list structure and you can understand, okay, this is called as a list in Python, or this is called as a dictionary in Python, and how we are basically creating a series out of it. Okay, so we have seen multiple structure. I proceed further with one more. Last structure is called as a numpy. Numpy we have seen in last videos. So numpy as np. I again create an alias of it. I want to create a series out of a numpy data structure, which is normally called as an array. Hope you remember it. Let me go back, and I want to create a numpy. So I say numpy dot array, and I give some element to it. I say 1 2 1 2 3, and I provide the indexes equals to 1 2 3. So it basically creates a series from numpy array. It's pretty common, and again you can take a matrices over here, which basically define a different kind of structure for defining the series. That's how we can define a series. Now we can see multiple kind of functions which Pandas provides, and how to manipulate this data. So for defining this, I have one example which is written right over here, which gives me some cities and corresponding value. So I'm going to define the same structure, data structure, so that you can correlate it. And this is also available in your book. So this slide is also available in the slide share. So you can download it. And this example, I also save it down as normally we do. On the slides here, you can directly go and download this data whenever required. So once data I want to define, it's basically a dictionary which have some value. So I take some value here. I say Pune 2000. I say Bangalore 2800. I say Mumbai. Let's say I define some value is called as 2200. Okay. I say Chandigarh. It has some value. Let's say 1800. I say Raipur. Raipur have some value. Let's say 9999. I say Indore. I have some value, let's say 1000. So I'm defining a data structure here, which is a dictionary, and I want to create a series out of it and do some data manipulations with the help of it. Indoor, I have, let's say Daman. Okay, I said Daman. I don't have any value as it, so I make it none, and I take one more. Any city which comes to my mind first. Delhi is left. Okay, so I take Delhi, and which defines some value, let's say 1200. Okay, now I define a data here. Now this data contains some cities and some value. You can take any value. It can be population density per square meter, I would say. Okay, or anything. It's population, I say. It's pollution, whatever. Okay, I want to create a series out of it. So I say all cities, okay, equals to pd dot series is my name of a function. So it's the name of a function series, and I define a data. Now my my cities has been created, which has Bangalore, Chandigarh, Daman, Delhi, Indore, Mumbai, Pune, Raipur. The very important thing to notice over here is I define the value none here, but here it is nan. Now nan is again a numpy object which says not a number, not a number. So whenever the value is not available, it always give you not a number. I hope it is clear. So this is not a number because we don't have any value here. In Python it is none, in Pandas it is nan, or in NumPy it is nan. Now let's see how to manipulate this structure. So I give example by example. Okay, the first example is, let's say for example, I want to print some cities. Okay, I say what is the value corresponding to Pune? It's 2000. It's 2000. So I want to see the values of all Maharashtrian cities. So I say, okay, this is Mumbai. Okay, so Pune, Mumbai, it gives me the value 2000 and 2200. So I have to provide a list here to get multiple values out of it. Now, pretty important thing is, which you did not notice, I think, in this example. If you talk about a dictionary, we cannot have a duplicate keys. We cannot have a duplicate keys. Like every key should be unique. But in series, you can have a duplicate keys. That's fine. That's completely fine. So there is no problem as such. I give you one example into it later on. So I say cities, Pune. I want to update a value of Pune. Let's say instead of 2000, I want to keep the value as 1800. So that's completely fine now. It change a value and make it 1800. Does that make sense, guys? I hope everything is fine. Okay. So we have changed the value of Pune and make it 1800. Let's say, for example, if I want to add more cities at a runtime, let's say I want to add one more city called as, I take a simple city. I don't, okay, let's say Chennai. Okay, Chennai. And I want to put a value, let's say 2000. So that's also fine. I added a city over here. Let's say, for example, I want to change the value of multiple cities. That's pretty simple. I want to change the value of Chennai and Bangalore. 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 And I want these two values. Okay, Bangalore. And I said these two values, let's say for example, I make it 3000. Okay. Oops, 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 oops. Okay, now both the values has been changed to it. Now, this is a very simple operation. Now, apply some functions on the top of it. Now, let's say, for example, very first thing I need to do, I want to find out the name of all those cities which has the value greater than 2000, which has a value greater than 2000. So here we have Bangalore, here we have Mumbai, and here we have Raipur, and here we have Chennai. These are the four cities which have the value greater than. So if you are doing this operation in normal Python, you have to take a loop, go each and every value, but Pandas provide you the real structure. So I say cities is greater than 2000. So when you do this operation, basically you have used an operator over here called as a greater than operator, which compares each and every city's value and give you the okay, my mic has been disconnected, and giving the value here. Just give me a second, guys. My mic problem. I hope that you're able to hear my voice. Okay, my mic once again. Here we go. It's fine here. Okay, great. So I say cities is greater than 2000. So it means when I run this, it give you individual values. Like Bangalore is greater than 2000. Yes, it is. Chandigarh, it is not. Daman, it is not. Delhi, it is not. Indore, it is not. Mumbai, it is. Yes, it is greater than 2000. So you can use a different kind of operators here. You can say greater than, less than, greater than, equals to, any number of operators you want. But I'm more interested in the name of a cities rather than giving a true and false value. So I say cities, I take an indices over here, and here I say cities is greater than 2000. Whenever I'm doing this operation, it basically returns a true and boolean value. Now I say cities of Boolean value. So the corresponding values which are true only return those particular cities. So it gives me all these. So it gives me Bangalore is having the value 3000, Mumbai is having the value 2200, Raipur is having a value 9999, and Chennai is having a value 3000. So it become so simple. You can also use different kind of operator. Let's I simply say, okay, there is any cities which have a value 2000. No, there is no cities. I say there is a cities which have a value 1800. I remember that I have created, okay, 1800. Yeah, two cities, Chandigarh as well as Pune, both are having the values equals to 1800. Now, simple arithmetic operations we have used. We have using, let's say, add operation. So I say cities plus 200. So 200. So what it does, it add the value to each and every cities and increment by 200. Now for nan, it remains nan because again, it's not a number. So again, nan remains nan and all other values get incremented by 200. Now we did not assign it back to cities. If I assign back to cities, then the value get modified of cities. Now cities remain as it is, which was earlier, because I simply say cities plus 200. Similarly, if you do the multiplication over here, so it multiply each and every value by 2, but cities won't change. It remains same as it is. Oh, that's good. So you have do arithmetic operation, any kind of arithmetic operations you can able to perform on a top of it. The beautiful part, it works with each and every element you have available into your series. Let's proceed further. Let's see some function. Okay, might have you seen some functions earlier. It's a sum. I is a sum. I is a sum of cities. Okay, so what it does, it basically it has a nan value. So let me try to modify a nan value. So the cities. Okay, first function I introduce is null. Is null. So is null is giving you again true and false value. So it giving me boolean value. So I say cities is null. Just give me a second. Is null. Okay, it's a function, so I have to call the function. Okay, so it says only Daman is nan, rest all does not have any value. So I increment the value to it. Let's make it 0. Okay, so I say cities, whatever the values we have in the cities, if it has a null value, make it 0. I have a cities available, it has a value 0. Now it's a sum of cities. It works charmly. So what it add? It add all the cities. So I have used the Python function, which basically does it the operation for me. It has a lot of functions. Let's say, for example, if I want to calculate a mean of it, so I say mean. So cities is what? Cities is a Pandas series object. I just try to find it out the mean of it. It gives me the mean value as a city dot median value. Okay, as a city dot standard deviation. What is my standard deviation? It gives me the standard deviation. As a cities dot what is the variance of this particular values, it give me the variance. So all these things you don't have to calculate it. These functions are available, you can immediately use it. Let's say, for example, I want to find out those cities which has a greater value than mean. Okay, so I put like this: I say cities value is greater than cities dot mean. Only three cities which has a value greater than mean, which is Bangalore, Raipur, and Chennai. So it work very charmly, and you can utilize these functions to perform your different operations. Okay, some more functions we can just look into. We have defining the cities here, which contains multiple value corresponding to these cities, whatever we have. Let's say, for example, I want to find it out whether Delhi is a part of this particular cities or not. So it becomes very simple if you say Delhi in cities. So likewise, we have done earlier. So just check it out. Okay. So I want to check it out whether Shimla is Shimla is not in cities or not. Just supposed condition. Now, Shimla is not available in this particular city, so it give me false. It just do the for a validation purpose whether the data is available inside this particular series or not. You can immediately do that. Other thing is when you are storing this data, let's say for example here we know that Bangalore is stored at the 0th index and Chandigarh is stored at, this is basically called as a location. So going further, when we are going to discuss about data frame as well, this location become playing a very important role. So I say cities dot, there's a function called as iloc. When I give 0, it gives a 0th location. What is the 0th location I have? It's a Bangalore. The corresponding value is 3000. So it give me the value which is available at the 0th location. Similarly, if I say, okay, what is stored at the second location? It's 0 0.0 because it has a value. Daman is having a value 0 0.0. You can do that. You can also iterate through the values if you want. Let's say, for example, if I want to iterate through the values, I say for, I take a loop inside, I say number, whatever the number I get in cities, okay, and I print those numbers. But immediately, it immediately give all the numbers which are available over here. So that's quite interesting, and you can also look into multiple kind of functions available. If you say dir is a built-in function in Python which returns basically all the functions associated with this object. There are hundreds of objects, hundred of functions which are available inside this series. So if you want to explore it, you can just explore these values. I try to discuss some of them in next section, how to basically read the data from different sources. Like for example, here we have somewhere read operations as well as to write into the Excel, to write into the frames. We are going to discuss about all these operations in further classes. So that's all I have in series, guys. I start with next section called as a data frame, but I take a rest now. Maybe I can record this session today or might be tomorrow. And once I recorded this session, I get back to you with the recording as well as I store this information into, I give this location where actually I have put this slide as well as this execution. So I would say, I just give a name to it. So, okay, I create a new called as video session. I store it here, and again I take the same file. So I say series executions. You can have a look into it, and if you case you face any difficulties, you can get back to me in a class. I will love to answer your questions or answer your doubts. Thank you so much for your time. I see you with the next section, which is data frame. I hope I record this video soon. Thank you so much for your time. I hope you enjoy this lecture.